Hey everyone, and welcome to The Explainer, brought to you by Ford's College. I am absolutely thrilled to have you here today. So, in our last session, we talked a lot about the theory of contract modularity, right? Well, today, we're taking those abstract concepts and actually turning them into concrete, patent-pending code blueprints. We're going to look at the exact design patterns you need to build reusable, professional-grade smart contracts. Let's get into it.
Here's our architect's master plan for today. First, from principles to blueprints. Then we'll meet the 4 core patterns, move on to the Yield Vault blueprint, spend some time reading the smart contract code, and finally, putting it all together. Just as a quick reminder, we're right in the middle of the Creating Modular and Reusable Contracts module within the Solidity from Zero track.
Okay, so let's kick things off with a question that's probably kept you up at night at least once. Why do we keep copying and pasting the exact same deployment logic? Seriously, how many times have you found yourself reinventing the wheel, hard-coding addresses, and just manually typing out the exact same constructor scaffolding? In our previous lesson, Principles of Contract Modularity, we learned why separation of concerns matters. Now it's time to actually fix the pain of all that repetition.
Section 1. From Principles to Blueprints, Escaping the Spaghetti Code.
Notice the stark contrast here. On one side, you've got the monolithic approach. Think of it like carrying around this 100-pound multi-tool in your pocket just because you need a tiny screwdriver. It's just a messy, tangled knot of spaghetti code. But on the other side, we have the pattern-based modular approach. These are clean, separated gears working in perfect harmony. Cohesive interfaces and single responsibility design are what prevent accidental coupling, meaning, you don't break the entire machine just because you wanted to tweak one little gear.
Section 2. Meet the 4 core patterns. Your patent-pending toolkit.
First up in the toolkit is the factory pattern. Basically, a factory centralizes your deployment logic. Instead of repeating constructor parameters and post-deploy initialization over and over again, the factory just exposes a really simple create method. It handles the new deployments, or it proxies a minimal bytecode template for you. It's an absolute game changer for saving time, rescuing you from constantly duplicating all that boring constructor scaffolding.
Next, we have the registry. And honestly, this brilliantly fixes the whole lost friend problem. Imagine a dependent contract acting like a friend who keeps changing their phone number without actually telling anyone. Super brittle, right? Well, a registry is basically your smart contract phone book. It completely separates address discovery from contract behavior. So other contracts can always look up and find the components they need dynamically without ever having to hard-code a single address.
Our third tool is interface segregation. You can kind of think of this as a universal plug. You're designing these compact interfaces that only expose the absolute minimum set of functions that external callers actually need. By keeping that public surface area super tiny, external callers are completely shielded from your messy, complex internal implementation details. They literally just plug in and it works.
And finally, the library. Libraries are the ultimate shared manual for pure domain logic. They centralize your stateless, pure helper functions. If you find yourself writing the exact same math routine to calculate shares in, say, 20 different contracts, you definitely need a library. It stops you from copying identical code and completely bloating your deployments. Okay, let's review this technical spec sheet like lead engineers for a second. When do you actually reach for each of these? If you need multiple similar deployments with consistent initialization, use a factory. If you need cross-contract discovery without hard coding, go with a registry. Need to minimize your public surface area and limit privileges, interface segregation. And if you've got repeated pure logic that doesn't need to access contract state, just drop it in a library. Definitely keep this matrix handy in your mental toolbox.
So the absolutely crucial point here is this golden rule. If code is repeated across implementations and doesn't require contract state, it likely belongs in a library. I literally cannot emphasize this enough. Please do not confuse libraries with manager contracts. If your helper function needs to read or write to the contract storage state, it is not a candidate for a library. You've got to keep those libraries pure and stateless.
Section 3. The Yield Vault Blueprint. Building a real-world ecosystem.
Let's actually look at the assembly steps for this ecosystem. Step 1, we extract the iVault interface so callers know exactly how to interact. Step 2, we create a vault factory to stamp out new vaults reliably. Step 3, we register every new vault in a vault registry so they can actually be discovered. And Step 4, we add a ShareMath library to handle all the complex calculations. By separating all these duties, adding a brand new yield strategy later on means you only have to write the strategy-specific logic. The rest of the infrastructure? It's already handled for you.
Section 4. reading the smart contract code, inspecting the wiring.
First up, let's look at the iVault interface. Notice how incredibly small this is. It exposes only deposit, withdraw, and total assets. Other contracts are going to program strictly against this tiny public surface. They are completely oblivious to the internal storage variables or any of the helper functions the Vault might be using behind the scenes.
Next, we have the ShareMath library. It contains the pure helper toShares. Because this function is pure and stateless, meaning, it just takes inputs, does some math, and returns an output without touching the blockchain state, we can safely place it here. This is what allows us to calculate proportional shares perfectly, without having to copy complex math across a bunch of multiple vaults.
Then we have the actual Vault implementation itself. This contract uses the ShareMath library, it implements our iVault interface, and it encapsulates all the messy bookkeeping like _total assets and _shares. It cleanly overrides the interface methods, all while keeping its critical accounting variables completely private and protected from the outside world.
And finally, the Vault factory. This is where the heavy lifting happens. The create vault function deploys a new vault, immediately records its address right into an all vaults array, and standardizes the discovery process by emitting a vault-created event. It really is your one-stop shop for initializing new strategies safely and consistently. Section 5. Putting it all together. The finished machinery.
All right, so here are the concrete consequences of actually using these patterns. 1. You keep public surfaces minimal via interfaces. 2. You centralize deployment in factories. 3. You use registries for discovery. And 4. You move stateless helpers to libraries. Doing this gives you vastly faster iteration cycles, much clearer ownership of your code, and unit tests that only have to focus on a single, isolated responsibility. Trust me, it makes your life as a developer so much easier.
So I'm going to leave you with a little challenge today. What pure helpers are hiding in your monolithic contracts right now? Take a look at your own code base. Audit it. Find those duplicated math functions and get ready. Because in our next lesson, Building and Integrating Libraries, we're going to write a reusable library completely from scratch.
And there you have it. Your blueprint to modular code is complete. I really hope you found this breakdown as fascinating as I did. Keep building, keep refining, and keep learning. This explainer was brought to you by Forge College. For more deep dives into this subject and a ton of other amazing Web3 related topics, be sure to visit the website forge.college. Thanks so much for joining me, and I'll catch you in the next one.